You stole my heart of gold after my silver soul. Can you dig any deeper now? I gave you all I own, put you on this golden throne, but I'm a little stronger now. You cashed in on my promises, you know I'm too generous. Now I've learned to never help you out.
Hi everyone, and welcome to our Christmas special Jubilee 55th Dev Club. Who have guessed why there was LV in the title this time? Anyone?
It's Roman.
Yeah, exactly. It's Roman for 55. To be honest, we're thinking to get rid of it, but not sure yet. For tonight's event, we have a couple talks scheduled. First one is by Vadim Trifonov from Swedbank, one for sponsors. The talk will be about dependency injection, of pattern, and how to implement it. And the second one is a bit more on the DevOps side by Jevgeni Goloborodko about monitoring your application stuff. And for the second talk, we also have planned a little demo where we'll be give away jailbreak licenses. So you have a pretty good chance to get one of two. So stay tuned, and maybe you're the lucky one. And before we crack on, a couple of insights about us who gathered here tonight. And we ask you what languages do you prefer working on a daily basis. English is second popular choice. The first one is Java, really classic, and PHP is the least chosen option, which is also nice. And then we ask you also, like, do you work with code or people, or both? And according to the chart, almost everyone is working with code. Out of a bit over 100 tickets we issued, 91, if I remember correctly, 91% marked that they work with code, and around 50-something marked that they also work with people too. And there was only around 10 people who only work with people but not with code. That's it for the moment from my side. I welcome Vadim to stage, and please, you do so too.
Hi. So today we're going to talk about dependency injection. And my name is Vadim Trifonov. I'm leading iOS development in Swedbank. So my background is heavily in mobile engineering, so certain examples here in this talk will be definitely from mobile apps. So before we will start, I would assume that most of you are familiar with dependency injection concept, but let's have a quick show of hands. How many of you find it still somewhat confusing or not that clear where the dependency injection starts and ends and what the concept is all about? Okay, quite a number of hands, but most still find it they understand. Both answers are great because I have, for both parties I have something. So now quick show of hands, who uses some kind of library or framework for dependency injection? So most are using some libraries. And who are using their own implementation, like without any frameworks? Yeah, we have at least one person. So one person can relate, others might be interested. So yeah, read it. First, like, let me bring you up to concept of dependency injection in layman terms. So if some of you would like to explain a dependency injection idea to someone else who is not a technical person, so you can approach it this way. Like imagine 5-year-old kids and imagine that they need to have some kind of a meal, something to eat. So would it be a good idea for them to somehow find this or prepare this meal themselves? Hit the fridge, go shopping to the grocery store? Probably not. You don't want your 5-year-old kids or any 5-year-old kids going around and trying to prepare their meal on their own. So what the citation says is that it would be better for them to state their need, to say what they want. Maybe they can express what kind of a dish they want, but someone else, preferably their parent or some third party, will resolve this need for them, will provide what they need. So this is like the most fundamental or basic idea behind the dependency injection. Someone else provides you what you need. So, and then probably the next question, or like the question based on the title, is why pure? What the pure means. So the pure meaning that not using any kind of library, not using any kind of framework. Well, dependency injection is not about frameworks. It's not a container, it's not your Spring, it's a library, it's not any other framework, or Unity if you're from .NET or Dagger or anything like that. So first and foremost, it's a bunch of principles and patterns, and that's it. So you can implement any kind of dependency, you can implement dependency injection with patterns and principles. You don't have to rely on frameworks. And there are like primarily two reasons why you would want to do that. So first is a really easy one. We see no shortage of languages appearing which have no established communities or code base or decade-old code open source libraries like Java or .NET have. So with languages like Swift, Rust, Go, Dart, Solidity nowadays, we still end up figuring out on our own what we should do about dependency injection. Whether we inject anything at all, or we end up doing something else. And the second reason is that maybe for some reason you don't want or you don't like invasive dependencies. So frameworks like Spring, especially Spring like Juice and their counterparties in .NET, they're quite invasive. So depending on certain circumstances, you might not want to have @inject annotations or something like that. Of course, in Java nowadays, as far as I know, it's sort of already almost on a language level provided to you. So it's like less of a choice or a problem. But in many languages, you still might not want this dependency or on the third-party framework. So if you can relate to the second opinion, well, you're not alone. Actually, Uncle Bob wrote in one of his blog posts that he doesn't want his code to be riddled with @inject annotations, and he wants to keep the frameworks at hand's length from his code. And there are certain circumstances where it's useful. For example, you're rapidly prototyping something, or you're not sure with what framework to go, or you're building your own small application, or, as we said, the language simply doesn't have any kind of good libraries. So you can sort of use patterns and principles that I will show you and have dependency injection advantages or benefits with you. So we will have two parts. First part is quite, I wouldn't say easy, but it's about fundamentals. So many of you are familiar with what I will tell. And the second part is rather complex. But I've tried to, as much as possible, to explain it clearly. And it will be about lifetime management. But let's figure out fundamentals. So if you feel you're new to dependency injection or not, you find it confusing, this is what you need to know to remove this confusion. And this is like where you start from. So we can say that there are mainly three obstacles in understanding and having dependency injection in your code. And I will show you three techniques how to avoid those obstacles or how to handle those obstacles. And each technique will be structured the following way. I will set the context. I will show you the problem which appears in this context. I will show you or explain the insight, how you approach solving this problem. And I will provide you with active argument, what you should be actually doing. So technique one is the most important, and it's about like the most basic idea of dependency injection. And I want to preface it with this quote. So probably some of you have already heard about or read somewhere that dependency injection is kind of like a $25 term for 5-cent concept. Of course, it's a bit of understatement. They're trying to underplay the complexity, but it's definitely about the first technique. It's definitely about the main idea of dependency injection. So let's set the context and see where we will find this idea. So you have two classes, standard situation. One depends on another. In my case, it would be, for example, some kind of a controller and some kind of application service. Controller, think not the some framework controller, your own controller, like interactor maybe. And you will quickly, if you're doing this for the first time, you will quickly stumble upon a first problem. Maybe momentarily, but you have to ask something from the service. And the question is, where does the service come from? Well, the most natural or like the straightforward solution to this is just simply to instantiate it, inline it here, where I have a comment. Well, most of you probably, I guess, know that this is not a great option, but why? Well, because you don't want to be tightly coupled. As soon as you would initialize service here, you have to know the particular implementation of the service, and you know a lot. You depend on this particular implementation. You know more than probably you should about this particular implementation because you have access to particular implementation. And you definitely now imported the framework or the module or the component where this dependency lies. And we have a virtue in software engineering called being loosely coupled, loose coupling. So when you are not relying on any particular instance, but relying on an abstraction, well, you're approaching being loosely coupled. And being loosely coupled gives you a lot of advantages. First and foremost, it's dynamic dispatch. If you don't know what kind of instance you're asking to do something, it can be dynamically picked for you at runtime. You have extensibility. For example, you can pass a decorator. You can decorate the service you want with a number of decorators which would implement some kind of aspects, logging, cross-cutting concerns. You can have parallel development. Well, I decided that I need this abstraction. If you know about clean architecture, I decided, for example, that it needs to do this and that, and someone else will implement it. There is a maintainability. Well, loosely coupled code is basically the essence of being maintainable. And testability. Well, it's easy to sort of put stops all around your code or object of interest and test it in isolation. So once we know that being loosely coupled is a good idea and we don't want to be tightly coupled, we need an insight how to solve this. And the insight here is that someone else, like the 5-year-old kids, should provide this instance to you. So in our case, it's an infrastructure. Something runs or calls your controller. And my active argument, for provision, you should use constructor injection. This is the most natural way. and from object-oriented perspective, the most clean way. So the simple constructor in language Swift will look like this. This is Swift. There is nothing special about the syntax, or I would not use anything special from the language itself, so it should be quite recognizable as any other object-oriented programming language like Java or C# or anything like that. So it's easy. We provide service to the constructor and we store it. And by the way, if you're using constructor injections for that, remember that your injection constructors should be really simple. They shouldn't be doing any kind of work. Their idea of them is to store the dependencies they're provided. Because when you're building a complex object graph, you don't want to be doing anything at the same time. So once we figured out the technique number one, and by the way, this 5-cent concept, providing dependency through the construction, let's see what our next stumbling block will be. Well, when you have now number of classes, everyone wants to be initialized with their dependency. Naturally, the question is, who is responsible for all those initializations? It's not me. It's not login router, someone else. So taking to the extremes the previous argument about or insight about the infrastructure, we can apply it here as well. Again, someone higher on the call stack is responsible for this. And the argument is that it's a notion of composition root, or concept of composition root. So the composition root, in words of Mark Simon, who wrote a terrific book on dependency injection called Dependency Injection in .NET, he said that the composition root is preferably a unique location in your app where you assemble your application from separate modules. And to provide you with an example, for example, in iOS apps, if you're familiar with them, the composition root would be your entry point to the application. And the first entry point to application is application did finish launching with options of app delegate class. For Android applications, it's onCreate method. For console apps, it's naturally your main method. And for Windows apps, it's app.xaml, at least to my knowledge. Now, the really simple composition root would look like this. It's a simple main function which takes some arguments, and you construct your object graph here. You initialize everything if you can, and you start doing something. Put things in motion. So in this case, it's really simple. We initialized authentication service, passed it to the login controller, thus resolving the login controller, passed the controller to the login router, thus resolving the router, and started the router. The really simple composition object graph. Sure. Once you solve this obstacle, there is one left. At some point, you will face the following issue. Now, you have a certain dependency, and it depends on the runtime value. So you cannot resolve it beforehand. You don't know this runtime value at compile time. So in this case, our account service tries to use some kind of authorized client. And the authorized client depends on the session token. And the session token is quite obviously something which we receive after logging in. So what to do about this? Our authorized client might look like this, which depends on this runtime value. It requires session token in its initializer. So we need a new insight here. So the insight would be quite similar. Again, we want to delegate this to infrastructure. We want someone else to care. But the infrastructure in this case now should promise us that given the runtime value at a certain point, it will return us the instance we're looking for. And what lies behind is the concept of, or the pattern abstract factory. And what's interesting about abstract factory in this case is that it's a double abstraction. Abstract factory is an abstraction on its own, which promises us the abstraction we're looking for. Meaning that it can be easily stopped to return stopped instances if we're trying to test something. So the abstract factory in Swift would look, or definition for that, would look like this. The protocol, you can think of it as an interface in Java or .NET. And it says that it will make us the client given the session token. Implementation is also rather simple. Given the session token at runtime, it will instantiate the authorized client. So this is sort of like a promise. We can pass this promise to our account service. Account service will use this promise and will resolve the client it needs. And if you're lucky ones who have first-tier functions in their language, like in Swift, we can simply state that, in this case, abstract factory is simply a function, pure function, which will take some argument and return the client we need. And it can be implemented like this. So let's see in action. We have a login router. Login router needs its client to do something, given the session token. Once we acquire the session token at runtime, we pass it to the factory. Factory creates us the proper client, and we can continue. So this wrap-ups 3 techniques. And it's enough, actually, to roll your own dependency injection. And it's definitely enough for simple projects and your own prototypes, and not very complex applications. So you only have to know about constructor injection and use it. You should compose your object graphs or instantiate everything in the composition route. And things that you cannot instantiate, well, provide factories for resolving at runtime. But, well, certain apps are quite complex. So we have to talk about the lifetime management. Well, so far we avoided somehow, or more or less, the lifetime management issue. And lifetime management is essentially how long something lives, how long it should live. And one of the important concepts regarding lifetime management is called scope. Essentially, the scope is how long or how many method calls certain object lives. And as long as object lives, we say that it's, for example, in a certain scope. And probably, if you're using frameworks, you should be familiar with the idea of scope. And usually, frameworks provide you with usually four scopes. It's no scope, or called usually prototype. It's your singleton scope or global scope, your session scope, and request scope. But thread scope. Okay. As long as your thread lives. Good. So let's take a closer look at what the no scope is all about. So in order to understand the no scope, think of 2 persons, Jack and Jill, arriving at campsite, and they need, for their stay, they need to brush their teeth. And they should be provided with a toothpaste. So every time they need to brush their teeth, they are provided with a toothpaste. Basically, toothpaste initialized for them and provided. So next time they need to brush their teeth, the toothpaste is provided to them. And so it goes. So basically, every time they need to brush their teeth, a new toothpaste is provided. There is no scope. Toothpaste is immediately discarded once no longer used. And it's kind of wasteful. The next scope, quite popular one, global or singleton. You can imagine, like, if Jack and Jill would have been provided with a single toothpaste, and both are using the same toothpaste. And the problem of this is quite obvious. For the whole stay, both of them will be using or sharing this same toothpaste, and you can expect certain collisions. For example, Jack is really wasteful, and Jill is really mad about this. So he used much more toothpaste than she did, and she's kind of now pissed off. And the toothpaste ran out. And behavior of, in this case, the state and behavior of the toothpaste was unpredictable for both parties. Not ideal situation, but we quite often encounter this in our apps because of the stale state or the shared state. What we need to solve this issue in this particular case is some kind of a custom scope. Think of a bathroom. Let's imagine that both are provided some camp booth on the campsite. Where is the bathroom? And the toothpaste now lives in this bathroom. So both Jack and Jill go to the scope of this bathroom, find their own toothpaste there every time, and quite happy because no one else uses it. The toothpaste won't disappear, it will live in the bathroom for the whole stay. So this is the idea of creating your own custom scope or defining custom scope or finding custom scope you need for your application. And the question is where those custom scopes are useful. So if you will go back to the request, for example, scope and the session scope applicable for server applications, these are kind of quite defined or predefined for you, which is nice because historically we define that certain things should live as long as the request lives, and usually it's very short, it's short-lived because request arrives, you want to process it as fast as possible and return something and deinitialize everything you initialized for this processing. With session scope it's a bit trickier, and if I'm not mistaken, nowadays usually we prefer to avoid the session scope and being stateless as much as possible. But in this case, it's naturally something lives as long as the session lives on the server. But in case, for example, interactive apps and mainly UI-driven apps, like desktop apps, front-end apps, mobile apps, you need deep scopes. You need custom scopes, which will be quite nested. And I want to show you an example of how it will look like to have custom scopes. So let's define the first scope, which is first one is really natural. It's root scope. It's your entry point application. It's where everything else, from where everything starts. And let's say the next scope would be session. And by the way, this example is taken from our actual app under development. It's a very small portion of it, but it's based on how we do things for production. So the session here, the idea of session is that it's a certain scope which observes the presence or absence of the session. And to make easier to you to understand what those root and session on the screen are, think of them as routers. You can imagine it as being a router. It's not a router from any kind of framework. Just think of it as, think of this, the small part of the tree you see, think of it as a top level object in this node. It's essentially something which represents the node in the tree and retains everyone else who lives at this node. So router is responsible for, in this case root router is responsible for attaching the session router when the application starts. And it's really simple. It just creates the session router when the time came and starts. The rest of the details are not important. So now let's go back to the tree. Let's make the actual tree. So as I said, session sort of observes what is happening in the system, and depending on whether we have session in the system or not, attaches another scope. Since we have no session, it attaches the logged out scope. Logged out scope attaches the welcome screen or the welcome scope, and the welcome screen presents the possibility to do the login. So once you press the login button, for example, the login will be attached. When you've successfully logged in, the session appears in the system. The session scope, by observing the appearance of the session in the system, or the session parameters, will detach the whole part of the tree because it's no longer needed, essentially deinitializing every dependency, and will attach the new scope called logged in, and will pass our session parameters there. The logged in will attach the customer scope, which is responsible for deciding which functionality is available. And as a remark, I should say that the customer notion here is from our banking apps. And it means that, for example, you as a user might have access to a certain number of customers. Your own customer, your wife's customer, your children's customers. So depending on the selected customer, you might have certain different functionality available to you. And the customer, in our case, attaches the account balance. Okay. So we have this scope hierarchy. And let's see, and by the way, before we'll see, if some of you are familiar with mobile development, only the scopes in blue actually presenting something on the screen. The rest here are to have this hierarchy of use cases. So let's see what kind of dependencies might exist at certain scopes. So the root scope naturally creates and retains the dependency of your initial configuration of your app. Session scope creates and responsible for keeping alive the session store because it's actively monitoring what's happening. Whether the session appearing, disappearing. But if you remember, when we logged in, the session token was passed, or the session parameters. And now logged in is able to create an authorized client. Because there is no guarantee that the authorized client will work because we have the required session token. Customer is responsible for observing the customer store, and then it can see what kind of customers are selected. And the balance wants account service. This is what balance uses to retrieve the accounts and their balance. So, if you're still with me, now will come the hard part. Because let's take a closer look what we have. So the balance wants account service, which depends on authorized client. And we know that authorized client can be initialized only with session token, meaning it depends on runtime value. We can make two observations here. First is that authorized client can be initialized only at runtime, meaning that we cannot pre-initialize it at compile time. Of course we could, but then we would have to make runtime checks whether we have session token or not. And if we don't, it's kind of exceptional state. We don't want this. We have this deep scope, beautiful deep scope hierarchy to avoid these kind of issues in principle. And the second observation is that customer node kind of has no dependency on authorized client because, well, customers were loaded when you've logged in, and they are only stored there. So the customer scope doesn't use the authorized client to download anything. It just observes the change selected customer in the customer store. So there is no natural need for the customer to know about anything authorized client. But the balance wants to know. And the problem here is that, well, how can we resolve account service in this situation? Well, what we can do is to take this authorized client, pass it to the customer scope or customer router when we're initializing it. For example, it can be as a parameter to this factory function. Pass it down the scope. Well, customer now sort of depends on authorized client. It definitely knows about the authorized client. It sort of stores it. And when the time comes, the customer will create the balance and will pass the authorized client. Balance will use the authorized client to resolve the concert, essentially passing it to the factory method of the method which resolves the account service given the authorized client. It kind of works. There is nothing like immediately wrong with that. We kind of have a problem here. Authorized client became a pass-through dependency. But we don't want that. This is not a good idea, because in this case, the tree is really simple, quite trivial. We have only one node in between. But imagine like 5 or 6 nodes, and imagine that the bottom node needs something from some dependency which exists on the top node, the top scope. Would it be a good idea to pass the dependency all along the tree downwards? No, not really. You would do a lot of busy work for that. And you would expose a lot of unneeded information to the scopes which don't want to know about this. So let's go back to the drawing board here and see what we know about scopes, or what scopes promised us. Well, child scope, in this case balance, should have access to all parent dependencies. And it means that it should have access to customer dependencies naturally, somehow should be able to inherit locked-in dependencies, somehow be able to inherit the session dependencies, and somehow inherit root dependencies. We don't know exactly how at this point, but it's a logical assumption. This is why we have scopes in the first place. We know that as long as a customer or locked-in leaves, their dependencies are available to us naturally, or should be available. And we want one more thing. We want fully static compile time guarantee that this resolving will succeed, meaning no runtime trickery, no any kind of sort of service location thing where you ask and hope that it will be there, or other crash or null pointer exception or anything like, or something like this. No, we want guarantees. So if it compiles, it will be resolved successfully. And if you're familiar with, by the way, quick show of hands, who are familiar with Dagger 2 framework? Okay, one hand. This is, 2 hands, sorry. I haven't counted my friends. So for you, you should be familiar now with idea of, or what the Dagger 2 promises. It promises the same thing. It's fully static compile time guarantee, because it analyzes your graph, your application graph at compile time. And we want the same thing. So how we will achieve that? Let's introduce a new abstraction. The component here name is, don't think about it. Think of it as a dependencies provider, something along the lines. The essential thing is that this is abstraction where we declare all the dependencies we need for this root node. And it's only abstraction. We don't know who will be resolving or how these dependencies, but we know that we want this abstraction given to us, and we will take our dependencies from there. The component name was borrowed from the Dagger 2 framework, so don't think that much of it. No. The important thing is that component will be responsible for creating its subcomponent, naturally. And now we have a whole tree of these component abstractions. So for every node, we defined an abstraction which sort of declares all the dependencies we need for this node. The interesting thing here is that the actual implementations of these abstractions, of those interfaces, let's say, will live not in the same physical place where they're declared. So we can imagine, like for root, for example, and the root component are declared in the same module, physical module, physical component. But I won't use the word component, not to confuse you. I will call it module. Think it as like kind of maybe library or something like that, whatever your language supports. So some boundary. And the white part here is where you assemble things. Is where you compose those objects in some coherent application. Remember the composition route? So think of those, the black side is a bunch of Lego blocks or modules, and the white side is where you put those modules together and you have an app. And this is where you will be resolving dependencies. The interesting thing, we implemented these interfaces. Now we have to resolve dependencies. How we will be doing this? Well, the things which are, we know that we should be initialized first because no one else initialized it before, because we are the first scope where this thing lives or appears. We will just simply initialize it in this implementation. But the things we cannot initialize, we will have to rely on our parent. And if you can see it, we have kind of, sort of, I want to use the word tricky, but it's not about trickiness, but it's a tricky inversion. Our abstractions know nothing about their parents. We keep the sanity. Our parent knows about its child doesn't know anything about the parent. But implementations, the nitty-gritty details, they can know about parent. It's only assembly, or meaning that assembling that, putting things together, that's very few code. So what it gives us? Let's first take a look at this part. Let's see how it will look like in code. Otherwise, it might feel a bit too abstract. So let's see how session router relates to its declared dependencies. We have the session router. What's important about session router is you can see that it has, for our interest, for our purposes, it has one component, its own component. And it asks from this component this make logged in component, the subcomponent. And given it, provides a session token where and is able to create logged in router. So the abstraction of this component looks like this. It declares that it will provide the session store for this session router and a way to create a logged-in component, essentially a factory method. And it's really simple. We have router and what we need for this router to function. After the session, we have logged in, and we have the same thing here. Logged in also has its own component. It uses the component to create the subcomponent and attach the child node. And its component is even more trivial. It just declared that it's able to create a subcomponent. So we've seen that the session router, how its session component abstraction looks like, and how the logged-in router looks like, and its logged-in abstraction, dependencies resolver abstraction. What's more interesting, let's now see how the actual implementations look like of those components. This is our, we've seen it already, session component abstraction. It still declares the session store, still provides the way to build the subcomponent, which is logged-in component. This is how you would implement it in the composition route, where you assemble things. Well, the session store is easy. We're the first to use it. It will live in our scope. We will simply instantiate it. And in order to create this factory method here, we will instantiate the logged-in component implementation, or our subcomponent implementation, and pass it one important thing here. Remember I said that we can depend on our parents? This is how this parent dependency happens. What's important that on the black side, we know nothing about our parent. But where we have nitty-gritty details, we know that we will pass ourselves as a parent to our subcomponent. Same thing here. logged-in component abstraction defines only the factory method, but the implementation knows that it will be passed as a parent, where we assemble things, the session component implementation. And it will do the same thing when creating its own child. It will pass itself to the subcomponent. Okay. Now let's go back to the problem at hand. If you remember, we still have kind of a problem here. At the balance scope, or now in this case, balance component should create us this account service which we needed. And we need authorized client, which lives in logged-in component. So let's see how can we now retrieve it with compile time guarantee. And I will show you the code for these three things. So we have our logged-in abstraction, logged-in component abstraction. We have our implementation. This is where our authorized client lives. I've omitted the detail, but the authorized client was initialized with the session token, which was provided when this logged-in component was created. So we know we are the owner. The authorized client lives in our scope. We pass ourselves when we're creating a subcomponent. This is our sort of non-interesting component of customer, which we have to somehow just simply pass through, or like it stands in between us and the one who is interested in us. The important thing is that customer component knows, implementation of customer component knows about its parent and passes itself to its child. And now this is the key thing here. This is where the magic happens. Given that we know all our parents, at the balance component in the balance component implementation, we can traverse through our parent tree, find this authorized client, and resolve the account service with this authorized client. And this is quite similar to things that the Dagger 2 framework does when it analyzes your graph and generates the code for you. But in our case, well, there is no one for us to generate this. And if you're writing your own implementation, you can use these techniques. So if you're not clear on the details, let's see what happened on the graph. What we did is that the balance knows that it wants accounts it wants account service. It asks the component for this account service. The balance component, being implemented by the balance component implementation, starts to resolve it. And to resolve it, it traverses up the tree, finds the component or the scope where this authorized client lives, acquires it, and resolves the account service for us. So this was the idea of how you can do things manually. So what we learned here? We learned that the deep scopes can be incredibly useful, especially in interactive applications, because they can decouple your use case and view hierarchy and allow you to avoid a lot of stale state. You keep only things you need, and you deallocate the things you don't need by having this deep scope hierarchy, not the shallow one, where you keep a lot of things at the global scope, a global state. We learned that component abstraction can be terrifically useful for hiding the implementation details of resolving our dependencies, but giving us some kind of a facade where to ask dependencies from. We've seen how segregated composition might be really useful in keeping your modules clean and unknowing about the nitty-gritty implementation details. And if you want a good analogy, think of your own apartment building, if you live in an apartment building where you have flats. So most of those buildings have on the ground floor or beneath the ground floor some kind of closets or something like this. where you can store things which you don't need in your flat. So usually when you go to this closet, you would observe that this ground floor, it doesn't hide any kind of pipes and wirings, etc. And you can think of this composition route and assembly place as of this place where these nitty-gritty details of how the things were put together exist and live. You don't have pipes, hopefully you don't have pipes and wirings running through your flat. You don't want to know about them. You just want water and electricity. Same kind of principle is here. Component abstraction, your facet, your power outlet, the place in the segregated composition where your implementations live. These are the wirings. And we learned that dependency graph traversal is tremendously useful for acquiring dependencies from our parent scopes. So this would be it from my side. If you have any questions based on the first part, on the second part, ask them freely.
Looks like you made it also clear.
or vice versa. Absolutely not clear what was it about.
Questions, any?
So I totally agree with you. You have to understand the scope, where your object lives when it dies, and that kind of things. But what it seems to me that writing or doing it yourself, you end up with a boilerplate which will transform into your own homebrewed framework, which will be similar to Dagger, similar to Spring, similar to any CDI or whatsoever. So it's just like you do it yourself. Like, what's the point?
Terrific comment, actually. You're absolutely right. We've been thinking now how we can sort of generate this code for these implementations. It's definitely can be generated. Whether it's worth an effort or not, it's questionable. The point here is that, well, Dagger is available for Java, but it's not available for Swift, Rust, Go, Dart. There are no such complex frameworks in certain languages. Well, if you don't have them, but you want all the benefits of this, you have to do it your own. And it's really useful to know how to roll your own, how it works, because it will allow you to understand better how the frameworks work. And in case you have no frameworks, or you want to quickly prototype, you could go only to a certain extent. I could have not implemented, for example, this deep scope hierarchy. I could just have used the first three principles and patterns, and that would be it. Used some global state. Well, trade-offs. But this is the point. Yes. But you're true.
You're jealous to Java, right?
Maybe one from my side is that it's maybe kind of unique to Java that you have like great variety of frameworks maybe for those kinds too.
Too many.
Yeah, too many. And especially for the new emerging languages such as Golang and Swift, you oftentimes end up building yourself very trivial. This is good.
Maybe you should not use this language.
How do you then finally get away from Java?
There are certain platforms where you simply cannot use anything else, maybe. Or it would be really painful to use Java. And moreover, with Java, well, I think nowadays, mostly if you're writing Android, then you would use Dagger, and it's fine. But, sorry, I will ask you in a second. But as a comment, if you use Spring, for example, Spring doesn't provide you compile time guarantee, and Spring can run into cyclic dependencies and can fail you at runtime. So there is a difference in this case. But there the Spring usually is used. This is not a problem. Okay.
So if main motivation is absence of frameworks in certain languages, why not to form all of these into a framework and start like open source and distributed?
Yeah, as I said, we're kind of, first of all, it wasn't like that obvious. We had this problem. Initially, we solved it with, as you remember, the passing down the dependency. And it's like it works. And we had this problem when we realized and recognized how we can sort of cleverly avoid it by looking into, for example, what the Dagger compiles and examining how actually the Dagger works. and it sort of inspired us to find a way. But taking it to the next level, sort of creating your own library, it's a lot of effort, and you might simply not have enough time for this effort. And there is no like, let's say we're currently only evaluating whether it's worth of our effort to try to do this code generation or not. So maybe.
Guess that was the last question. Vadim, thank you so much.
Next time, I have something to wear.
So let's have a break, eat some food, drink some tea or coffee, get back together in about 20 minutes for a second talk with Jevgeni. And yeah, happy holidays.
The night in. Welcome, my heart's so full. I'm devoting myself to the night. There's no motive. We're just listening. We're existing. Against the tide, I wanna forget you, but you pull me in. I know this ocean is far too wide. I wanna forget you, let me forget you. Push and pull, but you repel. Giving up this fight. Love and hate, we learned the lines. I'm don't feel I have one. I wanna forget you, but only time will heal. Too late to erase the bad we've done. I wanna forget you, let me forget you. Push and pull, but you repel me. I'm giving up this fight. Love and hate, we've blurred the lines. I'm giving up this fight.
close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on so fragile, like it was built to break off the handle. How'd we get to this place? We're leaving everything behind for new and exciting feelings, but I won't leave you. Will everything we know be lost and changed for something new? Only time will tell, but I'll be holding you. 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 Let's slow down. I wanna live right now. I'm not worried, thinking about tomorrow. I'm feeling everything I need from you. It's all I believe in. I know you feel it too. Will everything we know be lost and changed for something new? Only time will tell, but I'll be holding you. I'll be holding you. I'll be holding you. I'll be holding you. I'll be holding you.
Summer days burn me out, love just brings me down. Cold inside like winter leaves that slowly leave the ground. Hey, you come back, I wanna give you a chance. Love me like you used to, so we can learn again. The skin is getting brown, baby, drink your night away. Maybe we will not regret it, you will not regret me. Laying down under the sun, burning love cause we are young. No one tells us what's done wrong, cause it's just me and you. Yeah, it's just me and you. Yeah, it's just me and you.
It's just me and you.
Yeah, it's just me and you.
I've been watching you. Just come to me.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see.
Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all, standing tall.
Out 2 licenses for JetBrains. What was it? The whole package or idea?
Whatsoever.
Whatsoever. One of
whatsoever.
One of whatsoever. Interpret it the way you want. And Jevgeni during his talk will be doing the demo, and then this would be exactly the chance to get yourself a a license. So please welcome Jevgeni with his talk on monitoring application.
Hello, everybody. I think most of you seen the situation when something happened and you want to know what exactly happened, but you know nothing about that. So I'll try to tell you how to solve these situations and what tools you can use, and a bit about my experience, because I'm doing it for many years. So some words about me, there is some facts about me, but first day when I faced the problem that I need to know what happens with my server, it was when I installed my own house network. I was its administrator, and time to time somebody called me and said, "Oh, my internet browser doesn't show me anything, or it's just something broken, please check it." And I started to ask myself why I can't do, why I don't know about that before somebody came to me. And the motivation why to do the monitoring, because you have time for things you love. You don't sit in front of your monitor and check, is it okay or not? So, the main point, it's always bad if your client or manager knows about your outages before you, because it's all about your reputation. If you can't handle outages before somebody notices it, you have a problem. So you should fight it. How? Let's try to discuss it. There are a lot of metrics that you can collect from your systems. For example, it's operation system metrics, any kind of resources like memory, CPU, network, bandwidth, and so on. In different situations, different metrics are important, so collect as much as you can. Sometimes you just can find something interesting even if nothing happened. For example, you can find some dependency between CPU graph and memory graph or network graph. So there could be a lot of interesting statistics. If you use JVM language or some kind of virtual machine language, in most cases virtual machine infrastructure gives you its own metrics. For example, how it uses heap, what kind of thread pools are allocated there, how many threads, maybe connections, and so on. You can also collect these metrics and put it into the graph. A very important thing is garbage collection pauses, because if you have too long pauses, then something bad happens with your memory and so on. Of course, you need database metrics, because if you write or read too much, you want to know when you started to read too much, or some kind of bad things happens. For example, database size grows too rapidly and you have to do something, or maybe you see that there are too many locks happens, so you should change some queries and so on. But not only general metrics are important. Application metrics are even more important because you can find there more detailed information and more exact information. For example, how many errors are fired during some time. For example, if you have normal error rate 10 errors per minute and you think it's okay, in one day you can see that 100 errors happened. So it means that something bad happens, maybe some outage or some kind of security break and so on. It's very important to collect incoming requests and categorize them. For example, how many login requests, how many logout requests, how many status requests, and so on. So you understand the load profile to your system, and you, after all, you can try to repeat it and have, for example, performance tests and so on. If you use external API like Facebook, Google Service, Foursquare, it's very important to collect how much you use it, because they all have its own limits. You must be sure that you don't run out of these limits, or it could be just too expensive for you. Or there could be some delays, so you should know if once a day you have a situation when the server answers after 5 seconds. It could be a problem because it affects user experience. For example, if you use some maps and on some request user see results after 5 seconds, it's bullshit and it's not a service. And another thing is user activity monitoring. It's about user actions. In most cases, it's monitored internally inside of your service. You write some code to collect these metrics and tell to monitoring server. And it could be any activity. It depends on your application, on your business, and so on. Who needs these metrics? In most cases, people think that, oh, it's system administrator need it because they are responsible for its liveness. But not only. If you're a developer and you can see these metrics, it's sometimes help you to find a problem, to face a problem, to notice it when you wasn't able before. It's much easier than digging into log files because you see the result in very convenient way for you. QA can see how good how well your product works because in some cases they can try to find the dependencies between some actions and reactions on some hardware resources and so on. They can find new problems with it. Marketing surely wants to know how exactly service is used because they can understand that this feature isn't used at all, and so why we develop it? We just can throw away and focus on things that are used and that people want. And of course, management, they want to know volumes, how many users are coming to service, how many things they buy or sell and so on. So it's all about the money that they can earn with this service. So for them, it's also important. Here are some basic metrics types. A sample is just some snapshot of value in some time, like CPU load. Counters is just some integer or integer-like values that just increasing on some events. Rates, it's about how many megabytes per second came through the wire or something, or how many times you consumed some service and so on. Aggregations, it's application of some functions on the values during some time. For example, you can calculate max values, minimum values, average values. You can calculate difference, and percentiles and histograms are used to distribute values and into some groups. For example, 95% use this. 95% of users use some kind of feature. It's good. Or 5% of users use this feature. It's totally unused, and so on. And of course, question rises: what can I use for monitoring to have so much statistics? Because 10 years ago it was a problem, and I'll tell you a short story about my experience. There were in late 90s, we had not much tools. We had round-robin database with its tool, and we should write a lot of code to collect something to put into this database, and we used some libraries to draw these graphs by ourselves. It was totally a mess. It was MRTG that helped a lot with that, but a lot of custom code also were there. And map was big and clumsy, and it just didn't work with large volumes. So mostly we used such tools like top or stat with top. Actually, I still use it. In 2000s, these kind of services were popular, and they were much better. They had a lot of templates. They could connect to most known services and take some metrics from there, but it wasn't enough. I still used to write some code to collect additional metrics. In late 2000s, there were two most popular services that mostly solved all the problems, but there were some problems with extensibility, especially if you need some kind of application level statistics. So, and now it's popular. Two popular solutions is Graph-it with Grafana and a young stack called TIC-stack. It consists of 4 components. Actually, I use it for now, and it's separated on 4 main components. It's InfluxDB. It's a database that just collects data series. Chronograph, that is just a UI to show these all graphs and helps you to configure and be a service monitoring administrator. Telegraph, it's just a data collector that have a lot of plugins for different services and with protocols and so on. I'll show it a bit later. And capacitor, it's event processing system. In most cases, it used for notifications. So it can detect that some kind of limit was reached, and it notifies administrator or some kind of responsible guy about this event. So what I like about InfluxDB, as far as it not relational DB, it have very high performance for write, so it can write metrics very fast. It can write it with batches. It have SQL-like queries, so if you're familiar with any SQL-like database, you will easily write your queries because not much difference. No data schemas, so you just start a service and you can use it without thinking about what structures I need, what data types, and so on. It's totally forget about that. And it has out of the box some kind of downsampling, data retention. It clears garbage after itself if you need it, and a lot of different statistic aggregation functions that will. Yeah.
Is it a database specifically for monitoring purposes, or just like DEVCLUB for monitoring?
Actually, it was designed for data series and for write purposes. So if you want to read much, especially with some kind of range scans, selection by key, it doesn't suit well. We did some tests and it wasn't too good. For these purposes, I would recommend some kind of database like Cassandra or HBase. But if you need just statistics, not only monitoring, but any statistics, it suits well because you can then transfer the statistic in a way you want to show it.
But it's not talking about reading a lot, but about some like sophisticated reads. For example, you have like really deep nested documents being stored there, and you want to do stuff to it you normally would do to Mongo. That's very, very, very specific.
It's not document storage. It's in time series storage. In charge of this database is time. So
it's more like a DynamoDB.
I never tried DynamoDB, so I can compare. And showtime. First of all, I'll tell a bit about things I'm going to show. So I've made a demo container to demonstrate how it's all working. Here's the description of this container. So it's
a quick request. Can you enter presentation mode?
Can you see? Okay. So I just use standard Debian container, and then I just install all required packages. Nothing interesting till here. Then I install Nginx server that will provide us actually not really needed, but I just want to collect statistics from it. And supervisor that could be, it's a service especially for Docker to run multiple services in a single daemon. So then I just install all stuff required for tick stack, as you can see. Cassandra is not needed here. I just wanted to show it on demo, but haven't enough time for that. And then I just upload all configurations for these services. Oh, nothing really interesting here. Configs are really simple. If you see, it's just Nginx configuration and standard configuration file for Telegraph that collects something from your service. It looks like this. You say that you want to monitor it, and some kind of param that tells about how to connect to the service. For example, here you need only URL to status endpoint for Nginx that is built in. And in most cases, they are similar. I won't spend time for all of them. What you know more about it? Also, I use Docker Compose. That is just describe how I want to start this container, to not write long lines with Docker. So I just start this Docker file that I showed before, and just forward these ports that are influx related. Nothing special, actually. And now let's try to start it. Can you see it? So we start our server. Okay, it tells us that it started 5 services. One of them is not needed for us. And now we can try to open the web. So if I open on my local host, will get into these dashboards. So we can see here host list that was connected. If we have multiple instances of Telegraph on multiple machines, we will see this a lot of hosts. So you can monitor a cluster here. So each Telegraph is some kind of client that reports metrics to monitoring server. So actually I have a single machine here, so that's why we see only one. And some basic graphs you can see from the scratch. So you can see already connected Nginx graphs. You can see basic system metrics, and here is very convenient data explorer. So we can, as you see, here is a request that I want to use to draw this graph. So what it means? It means that we select from request table. It's called measurement in InfluxDB. Oh, you have a laser, okay.
The green button.
Oh, okay.
Other side.
Oh. So here's a measurement name, a database name. This is a retention policy, but in most cases, if you doesn't define them, you will have out again. And here we specify what fields we want to select. In where criteria, we can use time in any query, or if you specify text, it's some kind of indexes that you use to filter your group data. You can specify also there. So, but if you don't want to write secure code, you just can use this helper. So you see that, okay, here is a request. You have, oh no, this is not.
Maybe use
Let's try. Ah. Okay. So, for example, we can. Oh, it's not very interesting. Nginx. Okay, we want to show the Nginx requests. So we select engines, and here we see all the fields that we can show. For example, we want to see currently active and how many requests. So it starts to draw graph instantly. For example, if we want to filter something, actually there is nothing to filter, but we can check here and we will see only this host. For example, if you have multiple hosts. In next demo, I'll show a bit more. But it's easily to draw any graph from the metrics that you have. For example, let's try to. Come on. So very convenient. You can select any range that you need, double click, you return to range you want. But this is not really interesting because any monitoring can do that. Let's do something that is more interesting. So I wrote a bit application that will send us its own metrics, and they will be more interesting for observation. Actually, all this code you will be able to see in GitHub in the end of on last slide. There will be a link.
Is it including this tick stack configuration?
Yes, you can see that here is a Docker directory where you can assemble your own and an application. I wrote it on Scala because I'm a fan of Scala, but if you write in Java, for example, there is no problem to use this approach in Java because the library I used is Java library. I just adopted it in Scala code, so no any difference. What I do here, I just create a simple HTTP server that can handle some request. So this means that all requests that came to demo path will be directed here. Here is the get method. And if something came to root path, this kind of operation will send a metric to our monitoring server. Here is the name of metric and a map that tells what kind of tags I want to use. Here I define a tag type, what kind of request I'm doing here, and the value for the tag. I'm showing the form. So for those who doesn't know Scala, this is a general hash map here with one value. And the same way for other paths, you can find that I send metrics for different situations. Actually, this is an application that we will use to give you some licenses for IntelliJ. So I'll tell a bit what it does. So it shows a form that you fill your email and a rate today, place, how you liked it, and send it to the server. After we will see the results, and our random generator will select somebody who will win. This winner will show us who will be winner. This is standard resources, nothing interesting, just. But as you see, it constantly I sent some kind of statistics.
Question: how do you send the sticks? You serialize them to JSON?
Good question, I'll show you what this method does. Actually, I wrote a simple class that just wraps influx library. Well, as you see, here is influx library. In Maven repository, it's called influx Java, so you can find it in Google. On the start, it connects to influx, checks if database exists. If not, it creates one. Then I'm telling that I want to batch all the metrics by 1,000 measurements, or send every 10 seconds. So you will be sure that you won't overuse your network. You won't overload some resource, and you're sure that every 10 seconds, anyway, you will have these metrics, if they are. And I've created helper functions. Create tick, it means that just mark that some event happened, and create point, it's give not just tick, but also provide some value, for example, response time and so on. So you, in this case, you just specify map with key and value. It will be used for indexing. And in this case, you have extra fields where you just specify field name and its value. So, and then I use standard influx library where I create point in its format and write it to InfluxDB. All simple. Yeah.
How guarantee that it will do it in the shutdown? How much cost shutdown or you must
Why you need it, for example?
in some case, I will try to read some.
Yeah. Yeah. Actually, monitoring data is not the thing you can't lose. For example, if you require to have it, if you're afraid that you will miss something, just send every second. But it wasn't designed to be durable. For example, if you reboot your server, to keep all unsaved stuff. So in this case, you can invent your own will or use some kind of queues like GMS and so on. But actually, I never faced this situation when I can't lose metrics. If you stop virtual machine, it will flash all unsaved changes.
So it keeps, it aggregates the events in memory and sends everything.
Yeah, it's just for traffic optimization. You can switch it off and you send it instantly. Yeah. I tried it this approach with very big load, and I haven't noticed any problems on application side or on influx side. It could handle it without any problems. So it won't produce any excessive load. So, and let's start this application. Okay, quick enough. It's already working. And here is our demo. Do you remember these crocs? Where I kept these crocs stuff?
Rock. Downloads. The first tab. I think it's running already now.
Yeah, it's running, but I can see where.
The address you mean?
Yeah. Oh, maybe it was separate console. No.
Looks like it's not running.
Okay.
You need a hand?
Maybe. Куда закрылось-то?
Можно? Тильда здесь, да? Нет? А где у тебя тильда? Тут.
Там-то впереди что-то написано.
Is it tilde?
Okay.
I can't really see.
Давай. I'll Let's mirror the screen, yeah, it will be easier.
No. I think we're good. К 80 просто портим и все. Или HTTP. HTTP 80.
4 восьмерки. Okay, let's try it. So
the demo is running on a different port.
Yeah.
9000.
Oh, yeah. What I'm doing, I'm trying to show my local host available on the net. So, it's called demo effect. It always happens. Really? Okay, so everyone can open it on your device and try to I will try to show it in a big form. So. This URL.
generate QR code. Scan it.
Oh, it's just too many connections. Yep.
No.
Raise your hands who managed to connect it. Okay.
Oh, it's in grok limitation.
Yeah.
Actually, I see that somebody is able to connect.
For a minute.
$20 connections per minute. Nice service.
If you have to upgrade to paid plan.
Yeah.
Okay, then first 20 are participating in the draw.
But they can't move ahead.
Just 99.99.
So okay, you keep trying, but I'm show you what happens here. All those who will be lucky, they will have more chances. So what you can do here, you can write your email and rate this place. I like it very much, so I give 10. And we already have some votes. This is rate distributions. 3, somebody put 3. Okay. But we can see that for most guys it was big pleasure to be here. So but why I'm showing this? Meanwhile, I'm collecting this statistics, what is going on in my service, and how this metrics traps that I've placed in the code are telling me about service usage. Now if I return to my page with chronograph, I can select demo. This is a database that I created for monitoring of my application. And here we can see requests. So if we click value, we can see that there were, in most cases, main one connection, but it's already applied a function mean that wasn't what I wanted, but why too much? It's not really what I want to see.
Does it say there's always been one connection?
No, it can't be. Something.
Maybe this request is something different, like request count.
No. It should work.
maybe you explain to us what is going on and what is wrong?
Actually, it looks like statistics isn't can't reach a database, but I can't see any messages about that.
But I have an idea. That's
Yeah, it's demo. It always happens. But it was.
Maybe from here, maybe we can see some, say, business metrics, or like how many people reach the site, or how many.
This what was I was going to show you, but
Okay.
But I see that only one connection at a time. It just can't be. I'll check one thing. It worked, I promise. Okay, but some result that we can see that for each request type there should be bigger numbers. You can see that those traps that we set in the application, they are all here. For how many form views, how many results were shown, how many answers, and resource requests. So I expected a nicer graphs here. This is all about application data explorer, but you can also create some dashboards. They work similar to Data Explorer, but you can save them and use for everyday use. For example, you create some query. For example,
Nginx is supposed to show some graphs.
Yeah, we will place it. You say it, for example. Maximum requests, and for example, let's add Nginx graph. Nginx. So we can see that there were a bit more than one connections. So this same picture we should see in the requests graph. And we can see that 5 connections in parallel was the maximum count. So here we can sort them, we can move them, and so on, like general dashboard. It's if somebody used Grafana, it should look similar. And we can save this dashboard, give it name. And it will be saved in dashboard list for future use. But now we want to see who the winner. How many winners we will have?
We have two.
Two. Okay. The first one is this one.
David. All right. Congratulations.
I'll write down here. And second one.
Sergey from Plumber. All right. Congratulations to you too. In terms of how exactly do you get your licenses, I will pass over the contacts. The form required to fill like first, last name, and the email, right?
Just email.
Just email. Okay. You guys need to hand over your first and last name, so that then we can forward all the data to the JetBrains guy at DEVCLUB, Anton Arkhipov, and then you will be gotten in touch. This is how it will happen.
So let's return to the slides. And I'll tell a bit more about additional tricks because you can collect additional statistics using some general tools. For example, you can parse logs using just tail and grep and send some metrics using it because Telegraph can help you with that. Actually, this was the tool I used in the 90s, but I wrote my own solutions. Exec, you can run some script, shell script or Perl or Python that will return some values and you can send it to Influx and graph them. And there is also plugin that could read JSON data and send it to Influx in some way like measurements. And of course you can use database queries. For example, if you have some information about statistics in your SQL database, you can just select it and send. But don't play much with it because you can hit performance and make things worse. I'll just show you a quick list of plugins that Telegraph supports. Just to give the understanding of how many of them. These all services that it could connect to and take measurements from. It can even take measurements from Amazon, console, different databases, DNS, Docker, and so on and so on. A lot of them. So you can see that you can monitor almost everything. And Jinx that I showed you is just one of them. But it's not just important to collect metrics, but to react on them. So in most cases, you want to have some kind of notifications if something bad happens. For example, if you see that your disk is going to be full, you spend 95% of its volume. So you need to be notified that you should go and clean something or resize it and give it more space and so on. So the capacitor that is used in this stack supports emails, SMSs, Slack, Telegram, and many other canals as you want. So it has its own robots, but I just don't have enough time to show this kind of presentation. So,
question. So have you used Telegram? Does the Telegram still works? You know that you send a Telegram and the post office guy comes off.
That's an app.
it's application.
It's not quiz time,
So I try Slack. It works well. And of course, email and SMSs. That's all. If you have some questions, here is a repository that I showed in demo. You can try it at home. So if you have questions, I'll be glad to answer.
I think we owe a round of applause for Jevgeni. Now we have time for a couple questions. Any questions from the audience? Yes?
You showed us the scenario for alarms, or actually you just mentioned that it would be a good idea to have them, but you know, in real life, you know, rarely it happens that you know you get a single bad event, but often you get like cascading situations, you get cascading alarms, and you know, do you have any, I don't know, best practices on how to handle these cascading failures so that the notifications that you end up receiving, you know, that you won't drown in the volume, that how you manage it?
First of all, go and solve this problem. if you constantly receive the same alarm, you just go and solve it, or just turn off this alarm. Because if you don't solve this problem, why you want this alarm?
Oh, the question was a little bit different. So, like you mentioned, like everything was okay, and then at night just goes SMS non-stop because something is wrong.
Oh, if you see repeated alarms, actually you can play with state. For example, you send alarm when state changes from good to bad, and from, for example, from bad to good, like it used in Jenkins. If your build fails, you receive notification, and you can customize it to not send notification when state repeats, and only when state changes, you will have this notification.
So this is something that you usually have implemented in business logic, right?
Yes.
And similar question, like, but not on repeating events, but like if you have a lot of nodes, a lot of instances, a lot of data centers, and something global happened, for example, like all instances, all machines got affected. So every monitor, every instance will notify how that system solved this problem.
I don't think that it solves this problem, because you have a lot of triggers that fired at once. So it's okay in this case. But I don't think, if you have a global problem, then in most cases your monitoring will go down also.
Like imagine you have 100 nodes running, right? And then you get like a notification that one is down. Then like you want to know still if second, third, and fourth go down. But after that, you probably don't care anymore because you see the pattern, and then you basically ignore the notification and switch to.
Yeah, it could be like your dependency service is down, so all your instances come. So it's kind of
like a load balancer is down, and then okay.
Yeah. You use some other service, like let's say like Google in this example, right? And your connection to Google is broken, or Google itself is broken. So all your instances will have exactly the same problem, right?
Yeah, yeah. But then normally you either like you distinguish like is it like one node? It's like all nodes.
It's host-specific or cluster-specific problem.
Yeah.
But
yes, correct. I have a question too.
okay.
It's more of a general, like good practices of performance monitoring. Would you store and analyze access log together with other monitoring data or separately?
Actually, Nginx plugin shows you numbers that tells us how many users came. But access logs tells you a bit more about who came.
And where.
And where, yes. But if you need this information, so I actually tried to show it inside the application to point where user comes. But another way, you can just write some log parser that will send the statistics to monitoring server, and you will have the data that grouped by some request path, for example, or some kind of geographic location if you have GeoIP model enabled, and so on, so on. Actually, you can segment your data from access log in many ways.
But from your own practice, do you also use the TIG stack for storing and processing, monitoring this access log data?
As I said, I just get it from the application, not from access logs. But I have almost the same data, but in this format that I easier to put it into the influx. I just don't have to parse it.
I have a question. So ELK is not good anymore?
What?
ELK.
Elasticsearch, no, I use it, but it's a bit different thing.
Oh, you can do.
It's more, if you want to compare to these graphs, Elasticsearch for me is like some storage for logs where you can find log records that you need, but it's not about overview and so on. It's for digging deeper.
What do you think about Prometheus for metrics collection?
I've heard about, but never tried. I think it's paid solution, no?
No. We had a demo the other time at DEVCLUB. The last one at Playtech, Jonathan did on Prometheus and Istio and stuff.
Yeah.
Yeah, so the video is available on DevClub channel, so you can go look up.
Yeah, Istio is pretty
So that's it. Thank you, Yevgeny. Thank you guys for being with us for this Christmas special. Have happy holidays and see you in January then. Stay tuned.
I ain't feeling lonely, and I wanna admit it's time to end the ride. Fading it too slowly, were those gonna lift me up this time? You were the only one who got me tripping up inside. All the words you told me, am I reading something different from your eyes? See you, for a moment even hope that I could feel nearer. Heart is pumping, thoughts are running wild. We got a good thing going, while we gotta feel amplified. Staying till the morning, countless hours spending by your side. You look at me, I'm soaring, seeing all the truth behind your eyes. See you, for a moment even hope that I can feel you. See you, all that I wanted was to tell you that I need you. See you, for a moment even hope that I can feel you. See you, all that I wanted was to tell you that I need you. Now I'm finally right here with you. Now I'm finally right here with you. The voice is getting nearer. Heart is pumping, thoughts are running wild. We got a good thing going, while we gotta feel amplified. Staying till the morning,